Thanks. Okay, so here we go. Python, 5 minutes of Python doing science. This is about some work that I've done as a volunteer research associate at the University of British Columbia in Vancouver. And I'm going to start by taking apart that title. What the heck is operational oceanography? If you pay any attention to weather forecasts, you use the products of operational meteorology every day. So in earth sciences, running a model operationally means running it something like daily, driving it with the most up-to-date data from the real world that you can get your hands on. So weather models that are used for forecasts are run daily or more often using all sorts of data from weather stations all around the world. We're doing the same thing in the ocean with a model of the physics, biology, and chemistry of the ocean to forecast stuff in the sea. Okay, so that's operational oceanography. Now, what's Bloomcast? So Bloomcast is a daily run of a model called SOG that focuses on the area of the ocean just off the coast of Vancouver. There's a bunch of forcing data that we use to drive the model. And the forecast that we're updating is the date of the first spring phytoplankton bloom. Okay, phytoplankton are the little single-celled plants that are at the bottom of the food chain in the ocean. Spring bloom is like that magical time here in Ontario when the grass gets green and the trees burst into bud. Some of you know that as allergy season. Okay, so here's a map. So Vancouver's here, this is Vancouver Island, Seattle's down here, and the SOG model is centered right there at S3. This is a schematic of the physics of the SOG model. I don't have time to go into this in any detail, but there's a link down here to a video talk about it that's really good. Okay, why do we care about the spring phytoplankton bloom? Things higher up in the food chain depend on eating up all that plankton goodness. So if the spring bloom moves by a few weeks earlier or later due to climate change or something else, there's a timing mismatch, and then it's sad fishies all the way up the food chain. Okay, still with me? We've got an ocean model, we've got a crap load of data. We want to run the model every day to predict when the sea is going to turn green with tiny little plants. And we want to report each day's prediction to a website for other scientists and people like fish hatchery managers to use. And that's where the Python comes in. See, SOG is a Fortran model. And Fortran models are kind of the idiot savants of the modern computing world. They're really, really good at what they do, but they don't interact very well with things like data streams from web services and making nice web pages and that sort of stuff. So SOG needs a little bit of help to relate to the real world. And so I wrapped it in a warm, loving blanket of Python libraries. I'm just going to highlight a few of these. Requests. So everybody knows requests makes it really easy to get data from well-behaved web services. The group at Environment Canada that provides river flow data got a little too close to their lawyers or something, because they need to be reassured with every single request that you've accepted their terms and conditions. Fortunately, requests.session makes that easy to handle too. Cullender. Cullender is a validation and data serialization library that comes from the Pyramid ecosystem. You often see it in web apps. In this case, I'm using it to pave over. SOG's got a kind of an idiosyncratic input file structure and syntax that's kind of hard to deal with, and there's several thousand lines of it. So I pave that over use Cullender to pave that over with YAML to make it more readable, more flexible. In the end, SOG needs to report its results, looking nice on the web. Matplotlib and Mako do that for us. So here's not up. All right. Here's results from the last time SOG ran. There's our prediction, pretty looking graphs, and a log of how the bloom developed as it was run each day. So it's been running for 2 years. We got pretty good results in 2012. We found an issue. When we fixed the issue, we discovered we had really good agreement with both the satellite data and DFO crews that measured chlorophyll. 2013, we did some more work in that same area of the algorithm. NumPy and requests helped us again. Got great agreement with the satellite data, and this year we've got a ferry that's running across the strait 8 times a year, 8 times a day, okay? And we've got great agreement on that. Future, it's going to the Gulf of St. Lawrence. There's other things we can do with it. Some references, because this is academic work. And there you have it. SOG making ocean science happen every day.
Okay, we're just going to take a moment to switch over machines.
Do we have any questions on that last session for Doug?
I was just wondering how you interface with the Fortran program. Is it through files, or do you have a...
No, I actually run it through sub-process.
Sub-process?
Yeah, so we actually run three instances of the Fortran program for 3 different sets of conditions, and use sub-processes and actually run them concurrently on 3 different cores. Works beautifully.
Thanks.
Anyone else? If you don't want to run up, you can probably stand up and yell. We can hear you from here. Any other questions? While we're waiting? Okay. All right, I've got one for Doug. Did you find it stable? What you've produced, was it stable for the duration of your 2 years?
Yeah. It runs at about 7 o'clock every morning, and while I'm eating breakfast, I check the logs, and and you see the seasons developing in the, as we start this running typically around the end of September, middle of October, and it runs through until the end of April. The bloom normally happens sometime between the beginning of March and the middle of April.
Okay.
Yeah.
I'm just curious, is it shifting due to climate change or whatever in one direction or another?
Yeah, so there have been observations that show that the bloom is shifting by up to 6 weeks. And it's moved around different years. So there was a very detailed study in the Strait of Georgia called Stratagem between 2001 and 2005. And in that period, there was shifts by as much as 6 weeks. There's been hindcasts back 40 years that also show shifts. So whether it's strictly a climate change effect, that's a very big discussion to get into. There's also influences from things like the Aleutian Low and that sort of thing. So,
all right, thanks, Kenda.
Yeah.